Hello everyone, I am antonette.araveltriplea Baltazar and I am going to present the continuation of moving stairways and walkways. The following are the components for standard escalator installation. First is the truss. It is a welded frame that supports the entire apparatus. The trucks are steel angles attached to the truss in which step rollers are guided, thus controlling the motion of the steps. The picture shown beside is a three-section built-up welded steel that supports the moving stairway equipment. Next, let's dig into the components of the safety and braking system of an escalator. First, the motor and drive system. The motor powers the escalator by turning the main drive chain. The main drive chain and sprocket transfers the power to the step chain, which moves the steps. And the step chain pulls the escalator steps in a continuous loop. Second, the brake system. The machine brake is a primary brake applied to the motor shaft to stop movement when needed. An emergency brake engages when a fault is detected, while a brake disc with groove and brake lever is a mechanical brake setup. And lastly, the electromagnet controls the brake lever. When energized, it holds the brake off. If power is lost, the brake is automatically applied. Third, safety switches. A broken chain switch detects if a chain breaks. If so, it triggers the emergency brake to prevent uncontrolled movement. The reversal detection identifies if the escalator moves in the wrong direction, while the underspeed detection detects if the escalator is moving too slowly, possibly indicating mechanical failure or overload. So how does the safety system works? First, the motor drives the steps via main and step chains. Second, if something goes wrong, a broken chain is detected by a broken chain switch, and an incorrect movement is caught by the reversal or underspeed detection switch. Third, these conditions triggers emergency brakes and the electromagnet releases, allowing the brake lever to engage the brake disc, stopping the escalator. Fourth, the machine brake also engages to stop rotation at the motor. Now, in the red font is the balustrade with moving handrail, interior panel, deckboard, and skirt guard. The picture shown pointed by an arrow is the handrail. It is driven by sheaves powered from the top sprocket assembly. It is synchronized with the tread motion to provide stability to riding passengers and support for entering and leaving passengers. The picture shown pointed by an arrow is the transparent balustrades, which are made of tempered glass and are frequently referred to as crystal balustrades. Balustrade assembly designed for maximum safety of persons stepping in or off the escalator. Second, in a blue font is the truss, which consists of top and bottom machine room. In a top machine room, it includes the control panel, drive unit, drive chain, and sprocket, in which the sprocket assemblies, chains, and machine provide the motive power for the unit, somewhat similar to a chain drive of a bicycle. In the truss, we can also find the main truck, trailing truck, and moving handrail drive unit. Third, in the green font are the steps. It consists of step thread, riser, step demarcation line, driving roller, trailing roller, and step chain. Now, let's talk about the escalator planning principles. First, main floor placement. Escalators should be located directly within the natural flow of pedestrian traffic to ensure visibility and maximum usage. Strategic placement encourages intuitive movement and efficient circulation throughout the facility. Second, vertical arrangement objectives. Escalator configurations should be planned to fulfill specific design intents, such as first, enhancing exposure to merchandise in retail environments. Second, maximizing passenger handling capacity during peak hours. And lastly, third, providing easy access to key areas across multiple levels. Lastly, the reversibility and traffic flow considerations. In locations where traffic flow is predominantly unidirectional, consider escalator reversibility. This allows the electric stairway to adopt the directional surges. For minimal traffic in the reverse direction, a standard adjacent fixed stair can adequately accommodate user needs. In conventional design escalator, the drive machine powers the movement of the escalator. The main drive chain transfers power from the motor to the steps. The top drive sprocket engages the step chain to move the steps. Roller chain drive or handrail drive sheave are the one who drives the handrail, keeping it synchronized with the steps. Emergency brakes are the safety mechanism to stop the escalator in an emergency. While external machine room for rise more than 25 inches to 0 for larger escalators, machinery may be located in a separate space within the truss area. Next, the step chain. It is the chain that pulls the individual steps along the escalator path. Steps move along a top curved track at the upper end and follow a defined loop guided by internal tracks. In the track and guard system, track and guard ensures that both the steps and handrail follow the correct path safely and smoothly, while the handrail tension sheave maintains proper tension in moving handrail to avoid slack. At the bottom section components, bottom sprocket returns to the step chain back to the beginning of the loop, while carriage tension device keeps appropriate tension in the step chain to ensure smooth operation. And in structural elements, the deck is the top cover area that people stand near when entering or exiting, and the truss width is the full structural width of the escalator, housing all mechanical components. In modular design escalator, this diagram shows how escalator modules can be stacked to achieve various vertical rises. These can be stacked in series to build taller escalations. In configurations, single drive handles up to 20 inches to 0 rise. Two drives handles up to 40 inches to 0 rise, while multiple drives allows for unlimited rise as long as proper support and synchronization are maintained. In the second diagram, you will see the component breakdown. A step-link roller truck guides and supports the rollers beneath each step. Step roller truck directs path for the rollers to travel along. Drive unit powers the step chain. Handrail drive moves the handrail in sync with the steps, while handrail and continuous guide keeps the handrail securely aligned and moving slowly. This table summarizes the motor drive capabilities for modular escalators based on their width and number of drive units. It helps planners determine how high an escalator can go depending on its configuration. On the first drive, in 32 inches size, the maximum rise is equal to 30 feet to 0 inches, while in the 48 inches size, the maximum rise is equal to 20 feet to 0 inches. On two drives, in 32 inches size, the maximum rise is equal to 60 feet to 0 inches, while in 48 inches size, the maximum rise is equal to 40 feet to 0 inches. On three drives, in 32 inches size, the maximum rise is equal to 90 feet to 0 inches, while In 48 inches size, the maximum rise is equal to 60 feet to 0 inches. This concludes that, first, escalator width affects maximum rise. A narrower escalator such as 32 inches can achieve greater rise than the wider ones such as the 48 inches in the same number of drives. This is likely due to the reduced weight and load of narrower systems. Second, more drives is equal to more vertical reach. Each additional motor drive increases the total allowable vertical height. A 3-drive system is needed for very high-rise applications such as the multi-story or transit systems. And third, the constant motor power. Both sizes use a 10 horsepower motor per drive. The system's scalability is achieved by adding drivers and not increasing motor size. The advantages of modular escalators. First, they are stackable. Second, it has unlimited rise capability. Third, it reduces custom engineering, which uses standard modules to meet different building needs. Fourth, drives are inserted per 20 inches rise, giving designers control over power and efficiency. Now, let's compare the conventional design escalator versus the modular design escalator. The modular escalator is ideal for, first, large commercial centers with vertical expansion. Second, airports, transit hubs with ongoing traffic growth. Third, sites with tight timelines and tricky layouts. And lastly, fourth, projects anticipating future expansions. While the traditional escalator is ideal for, first, standard commercial buildings or malls. Second, low to mid-rise applications lesser than or equal to 60 feet. Third, projects with fixed layouts and limited budget. And fourth, simpler service environments. The following are the safety features. A. Handrails and steps travel at exactly the same speed, 90 or 120 feet per minute, to ensure steadiness and balance on up or down travel and to aid naturally in stepping on or off the comb plates. B. The steps are large, steady, and are designed to prevent slipping. C. Step designs and their leveling with the comb plates at each landing ensure against tripping as one enters or leaves the escalator. This is to be accomplished with 2 or 3 horizontal steps at each end of the escalator. D. The balustrade includes all enclosures as furnished by the escalator manufacturer. It includes the deck boards, inside panels, skirt guards, handrail guards, and comb plates. Details of these parts are designed to prevent catching clothing or packages being carried by passengers. Close clearances provide safety features near the comb plates and step reeds. E. Automatic controls of service brake will bring the stairway to a smooth stop if electric power or mechanical parts should fail. Passengers would then walk the steps as they would any stationary stairway. F. In case of overspeed or underspeed, the automatic governor shuts down the escalator. This prevents reversal of direction up or down and operates the service brake. G. An emergency stop switch is located near the comb plate or in some unobtrusive location. Building employees and adult passengers may operate the switch to stop the escalator. The electric controls also are arranged to shut down the stairway if by some accident is caused to reverse its direction. H. Adequate illumination must be provided by the building at all landings at the comb plates and completely down all stairway. Some designs of escalators are provided with built-in lighting. These are the 4 methods of fire protection in case of fire near escalators. First, the roller shutter. The movement is actuated by temperature and smoke relays that automatically start the operation of the motor driver shutters. Second, smoke guard. It consists of fireproof baffles surrounding the wellway and extending downward below ceiling level. The baffle is a smoke and flame detector. Third, spray nozzle curtain of water similar to smoke guard. Closely spaced a highly velocity water nozzle from a compact water curtain to prevent smoke and flames from rising. And automatic thermal or smoke relays open to all nozzles simultaneously. Fourth, sprinkle vent. It has the fresh air intake. It is housed on the roof, which contains a blower to drive air downward through escalator. Floor openings, while the exhaust fan on the roof creates a strong draft upward through an exhaust duct. These ducts, in turn, draws air from the separate ducts just under the ceiling of each moving stairway floor opening. 3 such parts separate wellway ducts are shown. Each duct has a number of smoke pickup relays that automatically start the fresh air fans. The usual spray nozzles or the ceiling near the stairway aid in quenching the fire. Moving walks and ramps are different from moving stairways in application, function, construction, and capacity. Escalators have primary function in the movement of large number of people vertically, when such vertical distance does not exceed approximately 5 stories. A moving stair performs this specific transportation function extremely well with minimum cost, space, and maintenance. Unlike the elevator and escalator, the moving walk or ramp serves a dual function, that is, horizontal transportation only or a combination of horizontal and vertical transportation. Now, let's talk about the application of moving walks. The principal uses of moving walks, also known as auto-walks, are to eliminate and or accelerate burdensome walking, eliminate congestion, force movement, and easily transport large, bulky objects. So anyone who has walked the seemingly endless distances in a major airport, carrying or dragging a heavy suitcase, can appreciate the necessity of a moving walkway. For this reason, air transport terminals have become major users of this item. Next, the application of moving ramps. The moving ramps that combines horizontal and vertical movement is principally applicable to move persons and wheeled vehicles vertically, to move persons who lack the agility required to use an escalator, and to vertically move large, bulky objects. Ramps have found an important field of application in multi-level stores where escalators are not feasible for shopping cart users. Such stores may also utilize rooftop parking that is made accessible to cart users via moving ramp. And that concludes the topic of Group 3. Bye!